Hi, in the last session, we had some high-level overview of VHDL structure. Now, in this session, we will cover this in more details with little more complex designs. We will also see the general syntaxes to write any VHDL design. So let's start. In the last session, we learned that the VHDL file has two major components, entity block and architecture block. Let's look at each of these components in details. So first is entity block. The entity block specifies the name of your entity, which represents our circuits. It also lists all the input and output ports of the circuit, which allows the data to flow in and out of the circuit. Now the entity block syntax. The entity block is defined using this syntax. Entity, entity name is port, bracket start, port name, colon, direction, data type, semicolon. In the last, bracket closed for the port and then semicolon, and in the last, and entity, entity name. So here the first line is entity, entity name is, so this declares the start of the entity block with the entity name. Now the second line is port, and this keyword specifies that this is the start of port declaration, which specifies the list of ports of your circuits. So next section is for ports. So port name, colon, then direction, then data type, and then semicolon. So this declares the port with its name and its direction, which can be in or out, and the data type. And in the last, and entity, entity name, semicolon. So this is the end of entity block. Now coming to the architecture block. So the architecture block contains the actual description of your circuits. Within the architecture block, we can declare and use our signals as per our needs. The architecture block is the section where we write the code to describe our circuit behavior using VHDL. Now let's see the architecture block syntax. So I will read this first. Architecture, architecture name of entity name is, then signal, signal name, colon, data type, semicolon, begin, then number of concurrent statements, then end architecture, architecture name, semicolon. Okay, so let's decode this. So architecture, architecture name of entity name is, so this line declares the start of the architecture block with the architecture name and the associated entity name. Now there is a section between this line and the begin keyword. You can use this section for some other type of declarations. For example, signal declaration. This is completely optional and you will use this section based on your project needs. For example, here we have written the syntax of the signal declaration. So it is signal, signal name, colon, data type, semicolon. This will declare the internal signals. Note that anything which you have declared here in this signal declaration and whatever which you have defined in the port declaration in the entity section, these all the signals will be available for use in the architecture body. Now the next line, which is keyword begin. So this specifies that all the declaration in the above section has been completed, and now from here we are writing our circuit behavior. This we call architecture body. And the last statement is end architecture, architecture name, semicolon. So this tells that now this is the end of architecture block. Okay, so this is the high level view of our VHDL designs. There are a couple of things which you must remember. Number one, that in the architecture body, every statement you write that executes concurrently. Means all the statements in the architecture body are concurrent statements. You cannot write any sequential statement here in this section directly. To write the sequential statements in your designs, you must need to use process block. Anything you write inside the process blocks, that will execute sequentially. You can write multiple processes in your architecture body, so there is no limitation on that. But although all the statements inside the process blocks execute sequentially, but all the process blocks inside your architecture will still execute concurrently. And this is very important to remember when you are using more than one process block in your designs. Number two is that you can declare any number of signals inside the architecture block. There is no limitation to that. You must need to declare all the signals between the architecture start and begin keywords. Number three, that entity block tells you about the input and output ports of your VHDL design. So you declare all the input and output ports of your IC here. Number four, that all the signals which you declare in the architecture block and all the ports which you declare in the entity block will be available to use in your architecture body. You can use all of them there. Now signals in VHDL. So you can simply relate it with the wires, which are not input or output of your IC, but they are just internally connecting your elements with each other. Do not worry, we will be talking about that in some time. Number 5, that VHDL file saves with the file extension .vsd, and you can use any editor for your VHDL coding. Congratulations, you learned the very basics of VHDL, which is needed to start your first VHDL design. So it's time to design the first simple circuit in VHDL and write full end-to-end program for this. So this is the structure which we are designing here. I hope now you can relate that the entity name would be my design. This entity will have 4 ports. Out of these, A, B, and C would be our input ports and D out would be our output port. This means that we have everything for our entity section, right? Now architecture block. So we can see that there is signal X which are connecting AND gate output to the OR gate input. We can also see that there is an AND gate which is connected with the input A and input B. The output of this AND gate going to the input of OR gate through the internal wire called as signal X. Also, input C is also connected with the second input of the OR gate. Now the output of the OR gate is our final output D out. So now we know everything about the architecture as well. So let's create a VHDL code then. Okay, so this is our real VHDL code for this design, which you can use in your simulation tool and synthesis tool. We will also do this in our practical sessions as well. So let me read this first and then we will decode this. So library IEEE semicolon use IEEE.std_logic_1164.all semicolon. Entity my design is port A in std_logic semicolon B in std_logic semicolon C in std_logic semicolon D out out std_logic. Now bracket close and then semicolon, then and entity semicolon. Architecture behave of my design is signal X std_logic semicolon begin X gets the value of A and B semicolon D out gets the value of C or D semicolon and architecture semicolon. So you must notice that we have added first 2 lines here for which we didn't talk much, right? And these are library IEEE semicolon and use IEEE.std_logic_1164.all semicolon. This package is mandatory to include here because if you do not add this here, your program will not execute. And the reason is in the basics, which we have learned in our previous sessions of data types. Because here we have used std_logic data type for our ports and internal signals. And this data type is defined inside the std_logic_1164 package. So if you do not add this in your VHDL code, then you will not be able to use their elements in your VHDL codes. So this is mandatory one for most of your VHDL designs. So add them by default in all of your designs. But this is not the single one. We have more packages and we talked about them in our previous sessions of operators and data types. Anyway, so entity declaration is very straight. Entity name is my design. Ports are A, B, C, and D out. All are std_logic type. A, B, C are input ports and D out is the output port. Now notice the semicolon at the last declaration of the port list. We didn't use the semicolon at the end of D out, which is the last port list. Instead, we need to use this semicolon after closing the bracket. This only applies to the last port declaration, and this indicates that this is the end of port declaration. Remember this because this is the very common mistake happens with the beginners. Now architecture block. So we declared signal X here. So this is also std_logic type. Okay, so we have declared everything for our design. Now let's start the expression for our VHDL design and tell the system that how my design will work. So in the structure, we clearly see that signal X is the output of port A and port B. So write X gets the value of A and B semicolon. Next, we see that the signal X and port phi connected to the OR gate input and the output is D out. So write D out gets the value of C or X semicolon. And you are done. Congratulations for writing your first VHDL design. Well, here is a small appeal. Although I have designed these sessions considering the absolute beginners in my mind, so that you do not lose the interest because of too fast learning. But still, I am interested to know that if the pace is good, or it need to be little faster, or even if it is fast and required to be little slower down. Please feel free to write in the comment section. In the next session, we will be doing our very first small projects with LED and switch. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.